Hey guys, this is going to be another C++ programming tutorial, and today we're going to be looking at abstract classes and pure virtual functions. So let's get started. For this tutorial, I have made 4 different classes: shape, quadrilateral, circle, and rectangle. And let's now look at each of these classes in turn. The shape class is going to be the base class for all the other classes, and it provides 2 functions that will be used by all the classes that inherit from it: print area and print perim, because those are attributes that all shapes will have, so that's why I put them in this base class here. Now this quadrilateral class inherits from shape, and it adds 4 variables, and if you're not a math kind of guy, a quadrilateral is simply a shape with 4 sides, and it also overrides the base class definition for print perim, and it basically just adds all 4 of these variables together. Now the circle class adds a protected member called radius, and 2 constructors, one default, one taking an integer, which sets radius, and it overrides both functions because circles use pi times radius squared, and print perim is replaced with circumference. I think I spelled circumference wrong. And this rectangle is mostly like the circle: 2 protected members. We have width and length, 2 constructors, and an override for both functions. So now we're going to look at abstract classes and pure virtual functions. So let's start off with an example. Sometimes you're going to make a class that's there just for the purpose of having other classes derive from it. And yeah, like this shape class here. So basically, this shape class is here just so other classes can inherit from this. And it provides these 2 useful functions that all shapes will have. But there's no way to provide a meaningful definition for these functions. Like, how would you find the area of a shape? You need to know what kind of shape it is first. So what kind of definition would you give these 2 functions? Well, the answer would be to make it into something known as a pure virtual function. And what you do is you go after the function declaration in the class declaration, and you put equals 0. And that turns it into a pure virtual function, which means that you do not need to provide a definition for this particular function. Let's go ahead to do this for this one too. Now, an abstract class is a class that contains 1 or more pure virtual functions. And an abstract class is a class that's there purely to allow other classes to inherit from it. Which means you cannot create an object of the type shape, because this is now an abstract class. If we try to do that, shape s, we get this nice little error here: object of abstract class type shape is not allowed. So basically you cannot create an object for an abstract class because these functions do not provide a definition. And that's not to say that you cannot have member variables. If I added like an int x, this would still be a perfectly valid abstract class. So you can have member variables if you would like. Now, the thing with abstract classes is all classes that inherit from this shape class are now abstract classes until they provide an implementation for all of its pure virtual functions. So if you look at this quadrilateral class here, it only provides an implementation for print perim, but no override or implementation for print area. Because it only provides definition for this one function, quadrilateral is still an abstract class, which I'll demonstrate if we go ahead and try to create an object, and we get that same error there: object of abstract class type quadrilateral is not allowed. So yeah, basically an abstract class, all classes that inherit from an abstract class remain abstract until all of its for pure virtual functions have been given implementations, which is demonstrated here by this circle class. The circle class provides an implementation or override for both functions, and it provides this definition here, which means circle is now a perfectly normal class, and we can create a circle object very easily, like so. And same goes for this rectangle class. Once again, it provides implementations for both the functions, which allows us to go and create an object of that type. Now, let's say quadrilateral. Since rectangle inherits from quadrilateral, if quadrilateral had, because quadrilateral provides an implementation for print parim already, all rectangle needs to do to become a normal class is actually just override the print area. So, because quadrilateral already provides a definition for print parim, so this print parim is now no longer a pure virtual function in quadrilateral. So all rectangle has to do really is override print area instead of overriding both. So yeah, that's it. That's basically abstract classes. They're very useful when you're creating base class objects that you don't want base classes that you don't want people making objects of because, well, they don't really exist. So just as a recap, an abstract class is a class with one or more pure virtual functions, and a pure virtual function is just a virtual function that you add equals 0 to the end of, and it means you do not need to provide a definition for that particular function. And all classes that inherit from an abstract class remain abstract until all pure virtual functions have been given an implementation. So yeah, I hope you've learned something from this tutorial, and if you like this video, please subscribe, rate. If you have any comments, feedback, or any questions, please feel free to leave them below in the comment section. And if you need any programming help, coding help, stuff like that, please drop me a message. And thank you all for watching.